everyone! Welcome back to Singularity, your gateway to the future of the universe and beyond. Today, we're diving into one of the universe's most mind-blowing mysteries, black holes. These cosmic titans bend space, warp light, and even shoot out jets of energy that scream across galaxies. Buckle up, this is going to be a wild ride through the cosmos. If you're excited, smash that like button and subscribe so you don't miss more space adventures. Let's get started. So, what's a black hole? At its core, it's a region in space where gravity is so intense that nothing, not even light, can escape. They form when massive stars die and collapse under their own weight, squeezing their mass into an infinitely dense point called a singularity. But not all black holes are the same. Some are dormant, and some are active. Dormant black holes are the quiet ones. They're just chilling out there, not eating much. Think of our galaxy's supermassive black hole, Sagittarius A*. It's got the mass of 4 million suns but isn't gobbling up stars left and right. It's mostly dormant right now. Active black holes, though? They're the rock stars. These beasts are surrounded by stuff. Gas, dust, even shredded stars falling into them. As that material spirals in, it heats up and glows, making them light up the sky. Quasars, powered by supermassive black holes, are so bright they can outshine entire galaxies. Active or dormant, every black hole has some wild features. Let's break them down. First up, the event horizon. This is the point of no return. It's not a physical surface. It's an invisible boundary around the black hole. Once you cross it, gravity's grip is so strong that escape is impossible, even for light. That's why we can't see inside. It's a cosmic curtain. The size of the event horizon depends on the black hole's mass. For a stellar mass black hole, it might be a few miles wide. For a supermassive one like in the movie, it could stretch millions of miles. Fun fact, the famous black hole image from 2019? That glowing ring isn't the event horizon itself. It's light from stuff just outside it, warped by gravity. Speaking of light, let's talk about where it gets really weird. Right outside the event horizon is the photon sphere, sometimes called the light sphere. This is a crazy zone where light can actually orbit the black hole like a planet orbits a star. Imagine that. Photons zipping around in perfect circles. It happens because gravity bends light and at just the right distance, about 1.5 times the event horizon's radius. The bending is so extreme that light gets trapped in orbit. If you were somehow floating there and didn't get spaghettified, you'd see the back of your own head as light loops around. But don't get too comfy. Any nudge inward and you're toast. Now, let's zoom out to the accretion disk. This is the swirling, glowing pancake of doom you see in black hole pics. It's made of gas, dust, and debris spiraling toward the event horizon at insane speeds. Friction heats this stuff up to millions of degrees, making it shine in X-rays and other wavelengths. The disk isn't flat like a CD. It's warped by the black hole's gravity and can look like a glowing halo from certain angles. For active black holes, this disk is their fuel source, feeding the chaos. And that chaos? It leads to some of the coolest stuff black holes do, like jets and Doppler beaming. Enter Doppler beaming or relativistic beaming. This is what happens when stuff near a black hole moves at near light speeds, like in jets or the accretion disk. Picture this. Particles zooming toward us squish the light waves they emit, making them brighter and bluer. If they're moving away, the light stretches, getting dimmer and redder. But it's not just a color shift. At relativistic speeds, the light gets focused into a narrow beam, like a flashlight pointed right at you. If that beam's aimed our way, the black hole system looks way brighter than it really is. This is why some jets from black holes look so intense. It's nature's spotlight, powered by relativity. Speaking of jets, holy cow, these are epic. Some black holes shoot out massive streams of plasma, jets, stretching thousands of light years. How? It's tied to the accretion disk and magnetic fields. As material spirals in, it twists up magnetic lines, and those lines act like a slingshot, blasting particles out along the black hole's spin axis, usually above and below the disk. These jets move at nearly the speed of light, and when they're pointed at us, Doppler beaming makes them pop. Think of blazars, black holes with jets aimed right at Earth. They're some of the brightest objects in the universe, all thanks to this cosmic firepower. Those jets wouldn't happen without magnetic activity. Black holes don't have magnetic fields themselves, they're just gravity machines, but the spinning accretion disk does. As charged particles whip around, they generate powerful magnetic fields. These fields twist and tangle, channeling energy into the jets and heating the disk even more. Scientists think this magnetic chaos also helps explain flares, sudden bursts of light we see from some black holes. It's like a cosmic storm brewing just outside the event horizon. And all this warping and twisting, it messes with space and light in ways we can actually see. Finally, let's talk about light and space distortion, aka gravitational lensing. Black holes bend space-time so much that light from behind them gets warped into weird shapes. From our view, you might see a glowing ring around the black hole with a dark shadow in the center. That's the event horizon silhouette. Above and below the disk, light gets stretched into arcs or even duplicated. If a star is behind the black hole, you might see it smeared into a curve or popping up in multiple spots. It's like a funhouse mirror, but for the entire universe. This distortion is how we got that iconic 2019 image, proof that Einstein's gravity-bending predictions were spot on. And there you have it, the wild world of black holes. From dormant giants to active monsters, event horizons to jets screaming through space, these cosmic oddities keep blowing our minds. What's your favorite black hole feature? Let me know in the comments. If you loved this deep dive, hit that like button, subscribe, and ring the bell for more spacey goodness. Until next time, keep looking up, because the universe is full of surprises. See ya!